Welcome to the first part of the House of the Dragon tutorial from the second season. This tutorial is going to be highly edited and very quick, so I'm not going to beat around the bush. Open Blender. Delete the three subjects from the scene, go to Geometry Nodes, create a new plane, add a geometry transform and set the X and Y scale to 60. Add a subdivide mesh, setting 6 for example in level, then create a group with both nodes. Give it some space, then connect the transform geometry scale to a combine XYZ, drag XY and level to the input group, and rename them. Exit the group and add 60 again to the X and Y scales, then re-enter the group. Organize the nodes a bit, then create a frame with the 3 nodes you created. Rename the frame to ground transform and change its color. We add a set position, a noise texture, then we connect a color of vector math. We change the mode to subtract and connect it to offset. We change the vector value to 0.5 to have the plane right in the center of the scene. We can change the noise texture values. Add a transform geometry and increase the Z scale. We create a space and add a set shade smooth. We organize the new nodes, add them to a new frame, then rename it to animated noise. We change the color, change the noise texture mode to 4D, and connect all the values to the input group. We drag the scale of transform geometry to a combine XYZ, change the X and Y values to 1, and drag the Z value to our input group. We create a panel, rename it to ground transform, and add these 3 sockets. We create another panel called animated noise and drag the rest into it. We make room again. Add a subdivision surface and drag level to our input group. We add it to the ground transform panel just after subdivide mesh and rename it. We add subdivision surface to a frame and change its color. We copy noise texture, vector math, and set position nodes, paste them and connect them after subdivision surface. This way, we use the first noise texture to animate the fabric and the second to give it more texture. We connect these values to the input group, create another panel, add the inputs we just created, and rename it. With the 3 nodes selected, we create another frame, rename it, and change its color. We make room again, exit the group, and adjust the values we want. Then we go to Animated Noise panel. For the W value, we'll type frame/100, for example. If we find it's too slow, we can change it to 25 instead of 100. Then re-enter the group. We create a set material node, place it in a frame, rename it, change its color, and add the input material to our group by creating a new panel. Well, that way we have everything organized. Let's rename our node to ground. Exit the group, rename the group node to ground, and rename the object to ground as well as the modifier. Let's save the project. If we look at the size of our plane, it's currently 120 meters. We can easily reduce it to 60. We don't need it. And we can change some values to suit our needs. We can also change the animation speed. and create a camera. Enter the camera view and adjust the position. I'm not going to create a camera animation like the one shown in the intro. We'll simply create frames at one point and another on the timeline. Next, we'll create a mask for our camera, hiding much of the geometry and making the interface much faster. To do this, we'll re-enter the group, make room, create a plane, rename it to ground mask, drag the mask to geometry nodes, select relative, and connect a raycast to geometry. We'll connect a Boolean math to isHit and the result to delete geometry. Since the camera is quite far away, it's not clearly visible. But this would be the result. So with the 4 nodes selected, we'll create another frame, rename it, change its color, then move our mask down the Z-axis to perform the cropping. We'll create keyframes so that throughout the entire camera animation, it crops out the areas we don't need. This will make the viewport much smoother. Once we've adjusted all the keyframes for our mask, we'll drag our mask object to our group and place it in ground transform panel. When we do this, we'll run into a problem. We previously created an expression for our 4 animation, and Blender uses indices of each of the inputs. So, since we changed the order of the inputs, the expression we entered earlier is now being applied directly to the panel, not to the value we want, W. To correct this, we can copy the expression, undo the last action to get the order right, and paste the expression. When we need to configure something, we can lower the resolution so that the entire interface works much faster. And when we're ready to render or want to run a test or something, we can raise the resolution again. And finally, we'll remove the camera from the collection, rename the collection to ground, deactivate our mask from the viewport, and personally what I like is to activate the viewport as well. We deactivate the collection and press 7 on the numpad to go to the Z view. Let's add a reference image and load of the original intro video. We lower the opacity a little, find the frame we're interested in with offset, create a new collection and rename it to threads. We add a Bezier curve, enter edit mode, select all the vertices and delete them. We select a drawing tool and start drawing the shape of the threads. Obviously it's not perfect due to the perspective, but at least we now have a reference for how it should look. Doesn't need to have many vertices, but I always like to add smooth edges, and now it's basically a matter of drawing what we want. We change the name of the object, create a new modifier, and rename it to threads_1_GN. We make room and add a resample curve with a value of 60, add a set position, and with both nodes, create a new group, drag town of resample curve, connect a combined XYZ to offset from set position, and drag Z value to our group. We'll rename them, decrease the Z values so that the curves are below the ground, exit the group, change the node name and label, re-enter the group, and make room again. And with the 3 nodes, create a frame. We rename the frame, change its color, and add a curve to mesh. We drag the curve file and connect it to a curve cycle. We reduce the radius and use the resolution to create the break, since each thread is composed of several threads. We add instance points, and since they are now instances instead of a curve, we get an error here, which we solve by adding a realize instances. We add a curved line and connect it to instance, select direction, and then reduce the length. This way, when we change the resolution, we get fewer threads. We select zip cap to make room. We arrange the nodes, and with these 4 nodes selected, create a frame, rename it, and change its color. We can arrange the frames and add a set curve tilt Now we add a math, change the mode to multiplay, and connect it to tilt. We add a spline parameter and connect factor to the first value, giving us more control over the rotation. We put them in a frame, change the color and name, and create a panel and enter all the values we're interested in. We create another panel. Start by dragging resolution, radius, and we change the names. We drag scale and realize all. We'll make some room, add a switch, change it to true, and drag it to our group. We'll change the name to enable and drag and drop value and rename it. Now we'll exit the group and configure it a bit. We'll go back into the group and disable instance on points. We'll add a geometry proximity, drag around, select relative, and connect to geometry proximity. We'll disable the collection again, and I just made a mistake. It's not geometry proximity, but raycast. We'll copy set position, paste it, connect it, and connect hit position to position. We'll add a mesh to curve. Change the Z value to 1, exit the group, and reduce its Z position to 10, for example. And if we enable the floor right now, we'll see that the wires are perfectly positioned. Okay, now let's make room of these two nodes and add an endpoint selection, setting it to start 0 and end 1. We add a store name attribute, connect it between curve line and instance on points, select Boolean, and connect selection to value. We name it threads. Then with this, we've saved all the end positions of each of the curves. We'll put these two nodes in a frame, change their name and color. These other two nodes in another frame, change their name and color. And add a delete geometry and a name attribute. We select Boolean and give it the name we saved earlier, threads. And finally, we connect attribute to selection, and we'll drag both values to the same input. Now we'll add a trim curve to gain control over the animation. Note that if we disable delete geometry, we don't get the effect we want. We put the two nodes in a frame, change the name and color, and add a curve to mesh. We copy the circle curve, paste it, and connect curve to profile curve. We reduce the radius and select fill caps. Okay, now we want the threads to move randomly, and above all, emphasize the beginning of each thread. To do this, we'll add a noise texture and connect the color to the offset of the set position. We add a vector math and insert it after noise texture. We change the mode to subtract and change the three values to 0.5. We change the mode to 4D in noise texture and give it these values. We duplicate vector math, change the mode to scale, and that way we can control the scale. Let's animate the movement by adding a random value, connect it, and add an evaluate on domain. We insert it and change it to spline. So we'll adjust the values a bit. Okay, now we'll add a spline parameter. Connect factor to a math, change to multiply mode, duplicate scale, and connect math to the new scale. This way, at first we have a lot of noise, and at the end we have little noise. Let's add a color ramp, change the first value to gray, and drag it around here. And now we'll change the values until we get something we like. And when we're happy with the result, we select all the nodes, place them inside a frame, change the color, and add a name. We're going to reorganize all this a bit. And now we're going to add the values we need to our group. To see what we're doing, we can change the 3D view to geometry nodes, lock the view, and that way, every time we make a change, we'll see it live. We start by adding the floor object, rename it, and change the name to that one as well. And now we're going to add seed, min, max. And from our texture, all starting with scale. We also add a vector math. We also add a math. We create a new panel. Then we add all the values that have to do with noise. We can change some names to make it more convenient. We add the start and end of trim curve. We add resolution and radius. We create a new panel. We add these two. We create another panel, and we organize bit. In the end, it's all about organizing everything and changing the name so we know exactly what we're doing. Remember, you can change the speed in the player so you can see exactly what I'm doing. I think I made a mistake here. Let's turn off scale and give it a value of 1. Removing it from our group. Let's change the noise values a bit. Okay, so right now what I want is to modify this ramp color value, but since we can't add it to our group, what we're going to do is create a driver. So let's create 2 sockets. Put them in this panel and rename them. Once we've organized them, exit the group, right-click on the value, copy as driver, go back to the group, and right-click on this value and paste driver. Repeat the same steps with the other value, but now we're going to paste the driver into the 3 color values, and all that's left is to change the socket options. And you can see we now have control over both options. By the way, I haven't mentioned this before, but don't worry about the values I'm setting here because we'll be constantly changing them throughout the tutorial, especially in the second part, which is where we'll finish the animation. If you notice, the wires are in the center of the floor, so there are wires both above and below. We entered the group, added delete geometry, and it's not connected here, it's connected after a set position. We change the mode to spline, and if we use is hit array cast, we connect it to selection. In fact, endpoint is better, and that way we're removing a lot of geometry from the scene. But I don't like the result, so we're going to change the position of delete geometry. Put it after curve to mesh, and use a copy of array cast. We connect geometry, connect is here, and add a transform geometry. And by slightly lowering the position on the z-axis, I like to look much better. We put all these nodes in a frame, change their name and color, and add a set material. So we create a new material, rename it as threads, and select it in the node. Now we'll select the camera view and place the threads in a position we like. As you can see, the threads are very far from the camera, so we'll center them. And we'll go to the camera, select depth of field, select this tool, and click where we want the focus to be and reduce the f-stop value. Once we're happy with the result, we'll return to geometry nodes and connect the material to our group. We'll create a new panel, place it at the end, rename it, and insert the socket we just created. And with that, I'll conclude the first part of the tutorial, and we'll finish with the second part. See you soon.